I got 258 over 270 in my A-level chemistry exam, and this is how I beat the examiner.
Okay, so the whole point of this Born-Haber cycle is that we're going to create multiple routes so that we can work out one of our enthalpy changes. Now, what we can do to form barium iodine is we can do the enthalpy of formation, or we can do the lattice enthalpy. So if one route is our enthalpy of formation, we can do another route, this one in green, where we do our lattice enthalpy. And if we define lattice enthalpy real quick, it's the energy required to form one mole of an ionic compound from its gaseous ions. Cool. So let's start here. We have barium and we have iodine. Now, iodine needs to change. It needs to be atomized. Yeah. So we're going to atomize iodine so that we go from I2 to 2I. And just know times this by 2, we have 2 moles of iodine. Then we're going to atomize barium where it goes from solid to gas. So we've done that. Ionization energy. It's the amount of energy required to remove 1 mole of electrons from an atom in its gaseous state. So we go from Ba to Ba plus, done. And then we're going to go from Ba plus to Ba2 plus, done. That's the second ionization energy. And just remember, whenever you're doing this, you need to add on the electrons. Yeah, don't forget that. So up is endothermic, down is exothermic. So now we have electron affinity of iodine, the amount of energy required to add 1 mole of electrons to an atom in its gaseous form. That's going to form us 2I minus. And just remember, times this by 2. Finally, we get to the big boy lattice enthalpy, which we're going to label X. So when we do the calculation from our Born-Haber cycle, this enthalpy change of formation, being our first route, we're going to make that equal to everything added together from the second route, and make sure to use values from your handy table here. So we're going to use those values, remembering to times by 2 when we have to, because we have more moles, and we're going to get minus 602 is equal to 1270 plus X. Yeah, you can do that calculation. Then we can rearrange for X to get our lattice enthalpy, and that answers minus 872 kilojoules per mole.